All right, so can someone tell me what the 7 does? Like, what do we call the 7 in the description? It is the amplitude and it's the vertical stretch, both of those things. All right, so this has a vertical stretch of 7. Because that's vertical, that means it's up and down. So that means that the y values are going to be impacted. I want to use the y values of the sine original function. So remember, the pattern is 1s and 0s, but the order is different for sine and cosine. So I am going to multiply the original sine values by 7. So the sine values are 0, 1, 0, negative 1, 0. So I'm multiplying them by 7. That's going to give me these y values. Anybody have questions on those y values? All right, so what does the 1/6 do? This is a little trickier because if it were in the front, it would be a compress. But when it's in the inside, it's the opposite. This is called a stretch. 1/6 makes the graph increase at 1/6 its original speed. It makes it slower. And making it slower draws out the curve, which is called a horizontal stretch. All right? So this would be a horizontal stretch of 6. You do it by the reciprocal. Anytime there's a stretch, your value needs to be a whole number, bigger than 1. So it would be a stretch of 6. So what I'm going to do to that is, because it's horizontal is x. So I'm going to change the x values. The x values of the sine and cosine function are the same, right? The original x values are the same 5 things. So what I'm going to do is I'm going to multiply them all by 6. And what you'll see is for the fractions, I used 6 over 1. So it's 0 times 6. Pi over 2 times 6 over 1. Well, that becomes 6 pi over 2, which is just 3, right? So I'm multiplying all of those out. Pi times 6 is 6 pi. 3 pi times 6 is 18 pi over 2, but 18 over 2 is 9. So that's why that's 9 pi. 2 pi times 6 is 12 pi. I'm multiplying all the originals by 6. And in blue, that's what I'm getting. The period is the length of time that it takes to get from start to finish. So to get from 0 to 6 pi is 6 pi, right? So the first value minus the last. Where do I end the curve? I ended at 6 pi. So 12 pi. I'm saying 6 pi. So the period is 12 pi. To get from 0 to 12 pi, it takes 12 pi to get there, to finish the entire cycle. Everybody okay with that one? All right, the negative. What does the negative do?
Reflect.
That's called a reflection. So there's a reflection over the x-axis. The number in front is bigger than 1. That's a stretch again. So I've got a vertical stretch of 3. But the 4 is going to speed up the graph. It's making the speed 4 times the speed of the original, which means this is faster. It's going to get done the whole curve quicker. Okay, so it's moving at a faster speed. If it's moving at a faster speed, it takes the curve and speeds it up, which actually makes it skinnier because we're getting through that rotation quicker. And the fact that it's getting skinnier is called a compress horizontally. It's moving it in. So this is a horizontal compress. I don't have that written, do I? Here, sorry. A horizontal compress of 1/4. When you have a compress, you've got to do the reciprocal. All right, so for those vertical values at the bottom there, I took the original cosines, 1, 0, negative 1, 0, 1, and I multiplied them by the stretch and the reflection. Now for the x values, because it's compressing, I need to multiply them all by 1/4. So I'm taking the original x values and I'm multiplying them by 1/4. And I'm just going to do top times top, bottom times bottom. So I end up with pi over 8, pi over 4, 3 pi over 8. And at the very end there, I end up with 2 pi over 4. But 2 over 4 is the same thing as 1/2. So I just reduced that fraction. The period is how long it takes to finish the cycle. This one gets done in pi over 2 units. That's when I'm done the table. So the period is pi over 2 to get from start to finish, which is 4 times the original speed. Right? It used to take 2 pi. Now it's taking 1/4 of that. It's quicker. Questions on this one? All right, let's look at the next one. 1/3 in front is going to shrink this graph vertically. It's going to get shorter, so we call that a vertical compress. Because it's vertical, it's going to affect the y values, and I need to use the sine y values. 0, 1, 0, -1, 0. I'm going to multiply those all by 1/3.
Are we going to memorize those values? Yeah.
The 1, 0, the critical values, you don't have to. You can put them in your calculator. Like if you put sine of x in your calculator and go to the table, you can see them that way. Everybody okay with the vertical part? I think the horizontal part is the hard part because I see, okay, it's a vertical compressive 1/3, so then it must be a horizontal compressive 1/8, but it's not. 1/8 is making the slope slower, and slower draws it out. So this is a stretch of 8 rather than a compress of 1/8. It's drawing it wider, okay? What that means is I'm going to take all of the x values and I'm going to multiply them by 8 because they're getting 8 times wider. So I'm multiplying them all by 8. Whenever I'm multiplying a fraction by a whole number, I like to put the whole number over 1 so that I'm doing like top times top, bottom times bottom. So that 8 pi over 2 is going to become a 4 pi because it's going to reduce. 3 pi over 2 times 8 is 3 times 8, 24 pi over 2. And that's 12. So I'm just reducing the fractions here. And the period is how long it takes to finish it. To get from the original 0 back 360 degrees to the ending 0, it takes 16 pi. So the period is 16 pi. The last one has the reflection because of the negative. Is this one a vertical stretch or compress? Vertical. Stretch or compress. What's the 6 do? Heard someone say stretch. Yep. So we got a vertical stretch. So I'm going to take the original cosine 1, 0, -1, 0, 1, and I'm going to multiply them all by -6. Those are both vertical changes, and that's how I get my y values. For the x values, the 5x speeds the graph up. So instead of finishing at 2 pi, I'm going to finish quicker than that, so something less than 2 pi. So the values have to get smaller, and the only way to get the values smaller is to multiply them by a fraction. So this one is a horizontal compress. We're doing the reciprocal of the 5. So I'm multiplying all of the x values by 1/5. The period for this one is 2 pi over 5. That's how long it takes to get to the end there. So we've made the graph taller and shorter and wider and skinny. Today what we're going to do is we're going to keep the height and we're going to keep the width. We're going to pick it up and we're going to move it left and right. Okay, so we're going to move things left and right. If we're moving things left and right, what's going to change, x or y? X. So we're going to keep working with the x's today, all right? We're not going to make it taller and skinnier any different than we did before. We're not going to make it wider and skinnier any different than the way we did before. We're going to keep all that the same, and then we're going to physically pick it up and move it left and right, which is going to impact the x values. But it's not going to impact the speed, right? Like if I'm not changing this, I'm just moving it, the length of time that it takes to finish it is going to be the same. So we're not actually going to change the amplitude or the period today. Those things will stay the same. Just the position of where the graph is what's going to change. So this is called a phase change, all right? and we're gonna do this in our toolkits. All right, so in your toolkit, I think this is page 4, maybe. It says phase shift. Is it page 4? 5? 5? All right. Page 5 of your toolkit's got this new vocabulary. Phase shift is going to be the C. So A is going to be the amplitude. It changes the height of the graph. B is going to be the period. It changes the speed of the graph. C changes the location of the graph, okay? C is called a phase shift. That's just what the vocabulary of it, okay? So these transformations are the same types of transformations you did in, I think it's course 3, maybe again in course 5. But when you move things left and right, they move kind of opposite of what you think. So when I see like a minus C, in my head, minus would be left, but it's not. A minus C moves the graph to the right, okay? So when you have a minus C, the graph is gonna move to the right, C units, whatever that value may be. And the way that you're gonna write it, like in the description, is you're gonna call it a phase shift of plus C. Because we're moving to the right, we're gonna add the C value to everything. And a plus C, even though it looks like it's gonna go in the positive direction, actually moves the graph to the left C units. And the way that we're gonna write that in the description is it's gonna be called a phase shift of, and because we're moving to the left, we're actually going to subtract the C from every value. So we'll do a minus C. All right. Since phase shift is a left and a right change, we are going to change the x values. But like if I'm referring to this as a race, right? Me moving the graph left and right is giving somebody a head start or like less than a head start. It's not going to change how fast of a runner they are, okay? If I give you a head start, you're still the same pace that you always were, right? So period is the pace that it takes to finish a race. And if I give you a head start, you're still running at the same pace. So a phase change does not impact the period. So I'm just going to add a special note. You don't have a space for this, but you can add it. Phase change does not change the period. And it obviously doesn't change the amplitude either, because amplitude is y values, it's height. I'm moving left and right, so it's going to have nothing to do with the height. It's going to change the location, but it's not going to change the speed. Period is the speed. Okay? So this is not going to change the period. The way that we get the period is going to be the same. How long does it take to start and finish the race? Right? So the first few examples are just phase changes. They don't have any periods. They don't have any amplitudes. It's just a phase change. Okay? So for this one, sine of x minus pi. When I see a minus pi, this graph is actually going to move to the right. So it's going to be the exact same graph as the sine of x. The curve is going to look identical. It's just going to pick it up and move it. So the minus is a right, but the way that we're going to write it, we're going to call it a phase change of positive pi. Because it's going to the right, I'm going to add pi. Alright? Phase change of plus pi. Everybody okay with that part so far? Okay. So this is going to impact the x values because left and right is x values. So I'm gonna take the original x values, and this is a sine function, but sine and cosine have the same original values, okay? So I'm gonna take the original x values, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to move them to the right. And to move them to the right, it's plus pi, right? The minus pi actually turns to a plus pi. I'm doing the opposite of this. So I am going to add pi. To each of those values. Now some of this addition is going to be easier than others. Like 0 plus pi is pretty easy. 0 plus pi is pi. Pi plus pi is pretty easy because this is like 1 pi plus 1 pi, so that's 2 pi. 2 pi plus pi is pretty easy. That's like 2 plus 1, so that's 3 pi. Those ones are pretty straightforward, but when you're adding pi over 2 to pi, when you're adding fractions, you need common denominators, right? So we did this in the last unit a little bit in the non-calculator part. If I want to add these two things together, I've got to give this a denominator of 2, but if I give the denominator a 2, I have to give the numerator a 2 as well. You guys remember that? So it really becomes pi over 2 plus 2 pi over 2. And now I can add them together. It's top plus top. It's different than multiplication, okay? So top plus top gives me 1 plus 2. And then when you add fractions, the denominator stays the same. And I'm going to do the same thing here. This is a fraction plus pi. So in order to add them, I'm going to create common denominators by giving the top and bottom the 2's. And then I'll add the tops together. 3 plus 2 is going to give me 5 pi. And then when you add fractions, the denominator stays the same. You okay with that? All right, now this was a phase change of plus pi. The graph moved right pi. The y values were not impacted. There was no vertical stretch or shrink. There was no number in front. So I don't need to change the y values at all, okay? The number in front is a 1. So if I go and try to multiply everything by 1, I'm going to still end up in the same place where I started. So because it's sine, I'm just going to go with the original sine critical points. Sine is 0, 1, 0, negative 1, 0. This is like, remember, this is like the unit circle, right? So when we start at the first point, the y value is 0. Then we went up. Now it's at 1. Now it's back to 0, negative 1, 0. That's where they're coming from. All right. The amplitude is the A value. The A value is the first value. If there's nothing there, you can write a 1. The amplitude is 1. Now here's the part that students get wrong most of the time. They want to tell me that the period is 3 pi. The period is the length of time it takes to get from start to finish. Start is not 0. This person got a head start, right? They started a little bit ahead. So the period is the amount of time it takes to get from start to finish, right? It's the last value minus the first, which yesterday was always the last value, but that was because the first value was always 0. Right? If I go back to the warm-up, the period was 2 pi over 5, which was the last value, but that's because this minus this is the same, right? The period was 16 pi, which was the last value, but that's because the first value was just 0. All of these started at 0. Now we're going to start to get head starts. All right? Another way to think about it is the period is unchanged from here. I didn't speed this graph up at all. So the length of time is still the same as the original, which is 2 pi. So this would be 2 pi. Start or ending minus start is your period, the length of time it takes to get through it. All right, let's look at an example that moves the other direction. So this one has a plus pi over 2. So we'll call this a phase change. So it's going to move the graph left and right. But the plus pi over 2 moves the graph left. And so that makes all of the numbers get more negative. So we'll call it a phase change of negative pi over 2. Meaning I'm going to take all of the original x values and I'm going to subtract pi over 2 so that I'm picking them up and moving them all left towards the negative direction. This is a cosine function and phase changes left and right. So I'm going to focus right now on the x values of the cosine function, the original one, even though that's the same as the sine. So the x values of the cosine function are 0, pi over 2, pi, 3 pi over 2, 2 pi. You already memorized them. They are the corner points of the unit circle. You did that in the last unit. What I want to do is I want to phase change them all by negative pi over 2. So I'm going to minus pi over 2 from all of them. And some of the math up here is easier than others. All right, so 0 minus pi over 2 is negative pi over 2. Pi over 2 minus pi over 2 is 0. That one's pretty straightforward. The next one's not though. Pi minus pi over 2. I need to make a common denominator here, so I'm going to give this a 2 and this a 2. And this has like a 1. So it's 2 minus 1, which is pi over 2. 3 pi over 2 minus pi over 2. 3 minus 1 is 2 pi over 2, but the 2's cancel out. So this is just pi. Oops. Two pi minus pi over 2, I need this common denominator, so I'm going to give this a 2, and that means I'm going to give this a 2. So that top actually becomes a 4 pi, because it's 2 times 2 pi. So it's 4 minus 1. So it's 3 pi over 2. The y values were not affected. The only thing that happened here was a left-right change. There's no vertical stretch. So the y values were not impacted. I'm just going to use the original cosine y values. 1, 0, negative 1, 0, 1. If that was sine, the numbers would stay the same. The order of them changes. The amplitude is the A value, the number in front. If there's not a number in front, then the amplitude is 1. The period is the length of time it takes to get from start to finish. So I'm going to take the ending time, 3 pi over 2, and subtract the starting time, negative pi over 2. That double negative becomes 3 pi over 2 plus pi over 2. Because I'm subtracting a negative number. And that's 3 plus 1, 4 pi over 2. It's not any different than the original cosine. And that's because I didn't change the speed. I didn't have a horizontal stretch or compress. I didn't change the slope of the line, if you will, right? It stayed the same. So the speed stayed the same. All I did was move it. So this is 2 pi. You're going to start to recognize if there's not a horizontal stretch or compress, then it's just 2 pi. You don't have to do the subtraction every time if you can recognize that. All right, we're going to try one that has multiple things. So let's look at this one. Let's talk about the 8. The 8 is in the beginning, so what is it? This is gonna be a vertical stretch. I'm just gonna say of 8. We normally say by a factor of 8, but there's not a lot of space on your toolkit, so of 8 is fine.
On the test, if you wrote it down instead of.
I'm fine with that. The key is that you wrote 8 and not 1 8. Sometimes that's the mistake, right? Do you know it's 8? I'm fine with that. Alright? Now, there's nothing in front of the x, right? There's no b. It's like a, b, and then in the parentheses is the c. There's no b, so there's no speed change, which means there's no horizontal stretch or compress here. I'm not going to put that in the description. So there's also a phase change. Alright, so we'll call the 2 pi a phase change. There is a phase change, and because it's plus 2 pi, that means the graph's actually going to move left 2 pi, which means the phase change is actually minus 2 pi. So the red is vertical. Vertical is going to affect y values. The blue is a left-right. That's going to change x values. So the y values are going to be impacted by 8 somehow, and the x values are going to be impacted by a negative 2 pi. I'm going to start with the y values. I think the y values are easier to work with because they're 1s and 0s. So this is the sine function, so I'm going to use the sine values. 0, 1, 0, negative 1, 0. And they are being stretched by a factor of 8, meaning they are being multiplied. It's 8 times the sine. They are being multiplied by a factor of 8. So I'm multiplying each of them by 8. 8 times 0 is 0, 1 times 8 is 8, 0 times 8 is 0, negative 1 times 8 is negative 8, 0 times 8 is 0. That's what we did Monday, the vertical stretch. Tuesday we did the horizontal stretch compress, that's the B. This doesn't have that, okay? So that would be when we multiply the values by that number, because it would be like 2 times x. This is x plus 2 pi, like it's addition, subtraction. So I'm going to take the original x values, 0, pi over 2, pi, 3 pi over 2, 2 pi. And I am going to give them a phase change. And this phase change is going to be a negative 2 pi, because it's left. So minus 2 pi. Sometimes that math is going to be easier than other times, right? 0 minus 2 pi. Hopefully you can do that one, right? Negative 2 pi. I feel like this one, pi minus 2 pi is pretty easy too. What's pi minus 2 pi? Negative pi, right? Negative 1 pi. And 2 pi minus 2 pi is pretty easy too. That one's 0, right? Anytime you've got like a fraction and a whole number, like this, pi over 2 minus 2 pi, you've got to give it a common denominator. So I would give this a denominator of 2, and then I've got to do that to the top. So this ultimately becomes a 4 pi there, right, when I'm doing that. So it's 1 minus 4. That's negative 3 pi over 2. And then same thing with the other one. 3 pi over 2 minus 2 pi. I've got to give this a denominator of 2, which means I've got to give this a numerator of 2. So this becomes 4 pi. So it's 3 minus 4. Negative 1 pi over 2. Or negative pi over 2. The period is not 0 because that would mean that nothing happened. You just didn't move, right? A period of 0 means you didn't even start, right? But something's happening here, it's moving, okay? So the amplitude is the height of the graph, and that's coming from the A value, that's your 8. And your period is the amount of time from start to finish. So I take the finish and I subtract the start. But that double negative becomes a plus. It's going to be 2 pi unless there's a horizontal stretch or compress. And there's not here, so it's 2 pi. You okay with that one? Alright, last one. This is not one that I would put on a quiz or test, unless it were extra credit. I am not going to have you on your quiz or test do a horizontal stretch compress and a phase change. That's a lot of work with fractions, so I'll separate those two concepts. But I figure if we're doing it together, you can see one, and then it's gonna be the extra credit on your test, all right? So this particular example has got a vertical compress, vertical compress because of that 1/5. It's gonna make it shorter. It's gonna take a height of 1 and shrink it to 1/5. So 1 to 0.2. Now it's a lot shorter. Now the 2 is called a horizontal. Now the 2 is like a 2x. It doubles the speed. When it doubles the speed, it makes this part faster. Right? And if you're faster, you're finishing the race in a quicker time, right? So it takes what was once this and shortens the length. So it's actually a compress, all right? So this is a horizontal compress. And since it's a compress, the of value needs to be a fraction, so we do the reciprocal. So instead of 2, it's 1/2. Okay, and then finally there is a phase change. And that phase change is not going to be minus pi. The minus pi is making it move to the right. And so this would be a plus pi. The y values are going to be easy. What I do with the x values is going to look complicated. Keep in mind, you don't have to do this on a quiz or test. It's going to be extra credit, but I'm going to show it to you anyway. All right? So, vertical change. This is a y value, up and down. And I'm working with cosine. So I'm going to use the 1, 0, negative 1, 0, 1. And I am going to make this shorter by a factor of 1/5. So I'll have a 1/5 here, a 0, a negative 1/5, a 0, and a 1/5. Which means it's gotten 1/5 the size, and the amplitude is 1/5. The amplitude is your A value in the equation. Now, a vertical compress of 1/2 is going to have us multiplying by 1/2. And, a horizontal compress of 1/2 is going to have us multiplying by 1/2. And a phase change of plus pi is going to have us adding pi. Order of operations, which one do I do first? Multiply or add?
Multiply.
I gotta multiply first. So I gotta do the blue first. And then I'll do the green. Order of operations says we multiply before we add. So I am gonna do this kind of off to the side here. I know there's not a lot of space, so maybe like on the bottom part of your toolkit. So I'm gonna take the first x value of 0. And I'm gonna give it a horizontal compress of 1/2. So I'm gonna multiply it by 1/2. And I'm gonna do that math first. Alright, so the compress has still got me at 0. But then I'm gonna move that plus pi. So the first value here ends up at 0 plus pi, which is pi. Now let's look at the second value of a cosine table. The second x value of a cosine table is pi over 2. So I'm going to work with the pi over 2 now. I'm just going to do this off to the side for space reasons. So I got pi over 2. And what I want to do is compress that by 1/2. So I'm going to multiply that by 1/2. And now I'm at pi over 4. That's the shrink part. Now I gotta move it. So I'm shrinking it. Now I'm moving it. I'm moving it plus pi. In order to do this math, addition of fractions, I need common denominators, right? So I'm gonna give this a 4 and this a 4. And so now I'm at 5 pi over 4. Multiplying and adding. The third value of the cosine table is pi. So I'm going to work with pi next. And I'm going to do pi, and I'm going to compress it by 1/2. It might help to make that a pi over 1. So you can do top times top, bottom times bottom when you multiply. So I get pi over 2. That's the compress. I took what was once pi and I cut it in half. Right, that's the compress of 1/2. Now I want to move it. And since I'm moving it to the right pi, I'm going to add pi. But to add pi, I need common denominator, so I'm going to give this a 2 and this a 2. So it's 1 plus 2, 3 pi over 2. Now I'm at the fourth value of my cosine table, which is 3 pi over 2. And I want to compress that by 1/2. So I'm going to multiply that by 1/2. That's the blue part, shrinking it. So 3 pi times 1 over 2 times 2. I'm at 3 pi over 4. If I'm cutting 3 pi over 2 in half. Alright, and then I need to phase change it by adding pi. In order to add pi to this, I need common denominators. So I need a denominator of 4 for this one. 3 plus 4 is 7 pi over 4. The last one I'm going to do down here, so I'm out of space. Alright, so it's the final cosine table value is 2 pi. And I'm going to cut that in half. So it might help to put this over 1, because when you multiply fractions, it's top times top, bottom times bottom. So that's 2 pi over 2. The 2's cancel out. Now that's just pi. And then I'm going to add pi to that. Period is not 2 pi. What's the period? Pi. Why? You gotta go start ending minus starting to see the distance between the two. 2 pi minus pi is gonna give me a period of pi. Which makes sense, hopefully, because it used to be 2 pi, but now I'm making the speed double. So I'm finishing in half the time. Right? Half of 2 pi. Again, that type of problem is only going to be extra credit. I'm not going to make you do a compress and a phase change. You're either going to do one or the other, not both. Alright? So far we've done amplitude, height, period, speed, phase change, moving the graph left to right. The only way we didn't move the graph is up and down. So tomorrow is up and down, which is the easiest one. Because changing the y values is pretty simple, alright? So we'll do that one tomorrow. Then we'll be done the unit and we'll practice.